Okay, this is a video on bounds. I'm going to do a separate video on bounds, basic bounds, then we're going to look at error intervals, then we'll look at truncation, and then we'll look at bounds in context, okay? Now, depending on what year and what class you're in, it will determine whether you're going to do all of it or just going to look at bounds. To proceed with this, you need to be confident with rounding. So if you're not confident with rounding, you need to go and look at my other videos on rounding, okay? Right, so I'm going to introduce to you today the idea of bounds, and I've written a little thing about what it is here. So when a number is rounded, we can work out the highest possible value that that number could have been before it was rounded, okay? And this is what we would call the upper bound. So for example, if you had a number that was 4.5, and that's correct to one decimal place, okay? The lowest it could be, for example, is going to be 4.45, because if it was 4, because then we look at the first decimal place, the number next door is 5 or more, so we round it up. Okay, you'll see in a minute. And so this is called, if we want to work out the lowest value it could have possibly been, this is known as the lower bound. Okay, so that's what we're talking about. We're talking about the highest number it could possibly be, and which is the upper bound, and the lowest number it could possibly be, which is the lower bound, okay? Now, we're going to go through a series of examples, okay? Now, I want you to know everything you know about rounding, but we're also going to have to slightly change the rules in the context of bounds, okay? So, 42 has been rounded to the nearest whole number, and we need to find the lower and the upper bound of 42. So the highest it could have possibly been the number, and the lowest it could have possibly been. Okay, so what I'm going to do is I'm going to write 42 in the middle, that's my number, and then because it's been rounded to the nearest whole number, I'm going to do a whole number above it and a whole number below it, like that, okay? I then want you to find what is halfway between these two numbers and these two numbers, okay? So halfway between 41 and 42 is 41.5. and halfway between 42 and 43 is 42.5. This bottom one is the lower bound of this number, and this here is the upper bound, okay? Now, instinctively, 41.5, if we were going to round that to the nearest whole number, here's the whole number, the number next door is 5 or more, that rounds up, so that rounds to 42, so that's very happy. Now here, if we were going to round 42.5 to the nearest integer, the nearest whole number, it would be 43. It wouldn't be 42. However, if we had the number 42.499999999, that would round to 42. Now, if you are in 10 set 3, I will have taught you before recurring decimals. Okay, now you could prove that this 0.499999 is equivalent to 0.5. Okay, I'm not going to do it, but everybody else, you just have to trust me, okay? It's always going to be a 0.5 or some sort of 5 on the end, okay? The process, you write your number here, you take one number higher, one number lower, and you go halfway between. Okay, let's look at the second one. So 56.3 has been rounded to one decimal place. We put the number we've been given in the middle. We go one decimal place higher. So 56.4, that's one decimal place. And we go one decimal place lower, 56.2. Here we went a whole number higher and a whole number lower because it had been rounded to the nearest whole number. Okay, we then choose halfway between. Halfway between 56.2 and 56.3 is 56.25. If you're struggling to know that, think about this as being 56.20 and 56.30, and this being 56.40, okay? Halfway between 20 and 30, of course, is 25. Similarly here, it'll be 56.35. So this is your lower bound, this is your upper bound. I'm using LB for lower bound and UB for upper bound, okay? Hope that makes sense. Right, this next one's quite tricky. We're going to do lots of practice on this, so if this is confusing you, just try and follow these steps, okay? You go one higher, one lower, halfway between. That's how you get the bounds. Okay, this one. So we've got 560 correct to the nearest 5 meters. So that means we've got to go 5 metres higher, which is 565 metres, and 5 metres lower, which is 555 metres. Okay, we're then going to go halfway between. So our lower bound is halfway between 555 and 560. Now, if it is not obvious to you what halfway between those are, you can very quickly add them together, 555 and 560, and then half it. And that is your halfway point, okay? The other thing I would say is, if we're, I did that one. That should say 557. Good one, Miss Callaway. 557.5, okay? Halfway between 5 and 10, halfway between 55 and 60 is going to be 57.5, okay? Hopefully you'll kind of get to know that. And then for the upper bound, we need to do halfway between 560 and 565. It is going to be 562.5. You'll notice that all of the bounds end in 5. Now that will always happen, okay? Whether it's a 0.5 or a whatever, a 0.5 or if it's 5 as the units or whatever, that will always happen, okay? So look out for that. Right, hopefully you don't need too many more examples on that. We'll keep going though. Okay, so we're going to do now a few more, just to keep us in handy. So 47.8 to 3 sig fig. So again, I put the number I've been given in the middle, and I need to go one higher and one lower, but still to 3 sig fig. So that the higher version of 3 sig fig would be 47.9, and the lower version of the 3 sig fig would be 47.7. Okay, then we go halfway in between. Here is the lower bound, so that's 47.75, and the upper bound is 47.85. Now in an exam, they would either ask you for the bounds, like I've just been doing, or they say what is the highest possible value it could be and the lowest possible value. Okay, so obviously this is the highest, this is the lowest. Okay, 184 to the nearest integer. Hopefully we can remember that integer means whole number. If you don't know that, make sure you write it down somewhere on the front of your book or something so that you've got it and you know. Integer means whole number. So we're starting with 184. We need to go a whole number higher and a whole number lower. Then we've got to come halfway in between. Halfway for our bottom one is our lower bound, be 183.5. And our upper bound, 184.5. Still remember, if you rounded that to the nearest whole number, you would get 184. Here, technically, you wouldn't. You get 185, but that is still the upper bound, okay? So we take that every time. Don't try and put 4.999. It's not going to work. It's 0.5, okay? 760 to the nearest 10. So we're starting with 760 in the middle. We're going 10 higher because it's been to the nearest 10, and we're going 10 lower in the middle. The lower bound is going to be 755, so that still ends in a 5, which is should. And the upper bound is going to be 765. Okay, 38,500 to 3 sig fig. So we're going to start with 38,500 in the middle. We need to go 3 sig fig higher. So 3 sig fig higher would be 38,600. And 3 sig fig lower would be 38,400. Okay. We need to go halfway between for the lower bound and halfway between here for the upper bound. The lower bound, of course, is going to be 38,450. Think about what's halfway between 400 and 500. 450, so that's 38,450. And the upper bound is going to be 38,550. Okay, the last one. 46 to 2 sig fig. So we've got to go 2 sig fig higher, would be 47. 2 sig fig lower, 45, and we come halfway between. So our lower bound is going to be 45.5, and our upper bound is going to be 46.5. You will notice that whatever the original number has been rounded to, your bounds are going to be one more than that. So here at the top, it was rounded to 3 sig fig, and then our answers, our lower bounds and our upper bounds, have 4 sig fig. 1, 2, 3, 4. 1, 2, 3, 4. Here it was rounded to the nearest integer, and so our bounds are to 1 decimal place, because that's one more than a whole integer. Here it was rounded to the nearest 10, and so it's got a unit as well, whereas obviously when we round to the 10 there are no units. Well, the units are 0. Okay, and here it was rounded to 3 sig fig, so it had 1, 2, 3 significant figures and the rest zeros. Well, our answer is going to have 4 significant figures. It's going to be 1 higher. Okay, that is an introduction to bounds.